I'm going to start with the very fundamentals of how user interfaces are built up. And mostly, they're all essentially a tree structure and an event loop. So the loop goes around the tree, as you can see. This basic format goes back to almost the dawn of time, not quite this far. I used to program on this thing. It has a different data structure. I think it just used a list of components because your interfaces didn't get very advanced back then. But it's got the event loop. It's got like a data structure where it stores which components are on the screen, and it's essentially the same sort of as today. This is Qt, which is a UI framework, a modern UI framework for C++, which you can see you have a tree structure with your typical components. You got a window on top, and you got like layout structures, and then you got buttons and whatnot. And this is like the recurring theme. And then we got the internet. Because mostly nowadays, you write your user interfaces using internet technologies. Like mostly, you use the internet to search for pictures of cats, but sometimes you deal with like business applications and whatnot. And that means you have to deal with a document object model. I struggle a bit to find a picture that sort of makes you feel the DOM as it should be, but Hieronymus Bosch delivered. This is the DOM essentially. And the DOM is extremely object oriented in all the wrong ways. Essentially, it was written in the golden age of Java, which means that not only is it object oriented, which in itself is not necessarily a bad thing. It's a meta-mutable state, where you use your objects to hide states from the rest of the application, and objects sort of encapsulate them, and you don't really have much control over what's going on there. And this is the thing we have to deal with. Yeah, it was designed for text documents. It sort of grew into something that you now actually build very rich interfaces with. But the problem is it doesn't translate very well to doing functional programming, because functional programming is, ideally, all your code is pure. Pure means that your functions don't actually cause changes outside of the functions themselves. They take input and they return output, and they don't depend on anything else in the universe. Which is great if you just want to have your CPU produce heat, but usually you have to generate some side effects. But the ideal of functional programming is that as much as you can remains completely pure, which means it's a lot easier to reason about it. And then when you have to, you produce side effects. And code, obviously, which manipulates mutable state cannot be pure. Because if you call such code twice, you might get different results for each invocation, and that is very much not purity. And the DOM does not map very well to these ideals. Fortunately, we have this thing called React now. Essentially, this is a different React. React is, it was hard to find pictures of React on the internet that don't look boring. Come on. React is essentially a JavaScript UI library from Facebook, which the most interesting part of it is that it's introduced the idea of a virtual DOM. Oh, sorry. Oh, that's better. I hope you could hear me anyway. Could hear myself a lot better now. Yes, where was I? The virtual DOM. The virtual DOM is essentially an immutable data structure, which is passed on to a diffing algorithm, which attempts to match the immutable part of the DOM, the immutable state of the DOM, to this data structure. So the idea is that your application simply produces a data structure, and React deals with the messy bits of the DOM, which gives you a much more properly functional way of dealing with this horrible thing. React introduced the virtual DOM, as I said, which attempts to isolate mutation to the rendering phase, essentially. so that you can write most of your application in a completely functional way, and when it gets to actually rendering, React takes it from there and doesn't expose you to awfulness, essentially. Except it doesn't really, because the rest of React is, it's got mutable bits. It's very neatly managed. React is a very nice framework for doing essentially traditional JavaScript development in a way that feels functional, but you still deal with side effects quite a bit. It's the state you deal with is still mutable very much, though it does a few tricks to make it less horrible. But there you go. It's got these issues still. But so this guy called David Nolan had this idea: what if React state was actually immutable? Because David's a Closure programmer, and in Closure we have this. Sorry. We deal with immutable data structures quite a lot, and we've learned that this is a good thing. And he thought maybe we could take the ideas, the good ideas in React, put them into ClojureScript, and get yourself a much more functional framework for doing this. And it's called Ohm. And Ohm doesn't have an official logo, so I went ahead and made one for them. Ohm essentially is React with the closure philosophy applied. It's got immutable data structures for its state. It's not entirely pure, but it's, as with closure normally, it makes a sensible effort to stay pure, except where you can't. It's the pragmatic approach to doing functional programming. Oh, going too fast. Yeah, I'm not going to dwell too much on Ohm, essentially. I don't have time to do that. I wish I could show you some of the cool bits, like the cursors, and even better, what's coming next. Because David just presented his ideas for like Ohm 2.0 at Euroclosure last week. And that's going to blow everybody's mind, I think. But I'm going to move on to Elm. Typo. Close it off. Elm essentially is a language that looks sort of a bit like Haskell, except it's very clean. It's very focused on doing the sort of UI programming that we're interested in right here. It's designed to be easy to learn and easy to teach. It sort of shies away from the more complicated things that you shouldn't really have to spend your mental bandwidth on. And it avoids category theory in all forms, because that just complicates things. The M word is never mentioned in Elm. It's there in the background, but you don't have to deal with it and think about it and worry that you don't understand it. And the interesting thing about Elm is it's provided this sort of architecture for how you build web apps in a purely functional style. It's sort of like MVC. You got a model. You got some events that can affect the model, called action in this case. And you got an update function, which I suppose that would be the model part, which essentially processes actions into changes in the model. And you got a view, which takes the model and turns the model into HTML. And there's a feedback loop there. In the HTML document, there can be things that produce actions, which is how it goes. So the feedback loop there is the messy bit, but Elm does a very good job of hiding it for you. It uses functional reactive programming, or something very, very close to it, as close as you can get in JavaScript, I would say, to accomplish this, to sort of tie the knot. And functional reactive programming essentially is, very, very simply, is the idea that you got something like a signal, which is sort of like a stream of data, but is really a value that changes over time, which you can react to when it does. For instance, you can have a signal which tells you where the mouse pointer is currently. You can have a signal which says whether the first mouse button is pressed. And you can have a signal that ticks with time. More interestingly, you can take signals and you can map over them. You can fold over them. So you can sort of create transformations, building like a pipeline. And in the architecture model, that's essentially what's going on there. You can think of the update as a map, and then you sort of pipe it into the view, so that whenever the model changes, the signal for the model changes. I believe I was slowed for that probably, yes. This is essentially how it's tied together. Your application is a signal that produces HTML. Your model is a signal which contains the current value of the model. Your view is something that takes, I'll ignore the signal address thing, that's for letting your component know where to send events that are produced. It essentially takes the model and generates HTML. And your actions is, in this case, this is where, so the view has an address, and the address points to the mailbox, and the HTML can generate events that goes into the actions feed into the model, and that's your event loop, essentially. I drew your diagram. To sum this up, you got actions which affect the model, and when the model changes, the view updates, and this gets fed into the DOM where the messy stuff happens, and the DOM can produce actions, and round and round you go. This is the event loop. This is specifically how it's done in Elm. The problem is when you want to start composing components. Because if you've got a very simple application, what I just show you is fairly straightforward to implement. But suppose you have like subcomponents, suppose you have things that you want to reuse everywhere, you can absolutely do that in Elm. The architecture model remains extremely elegant. You just get a lot of boilerplate. This is a contrived example of how to compose two counter components inside a larger component. And this is just the beginning of the boilerplate that you have to do. You have to make sure that you pass actions along correctly. You have to make sure that the state is initialized correctly and so on. It's not ideal. It's still properly functional. It still absolutely works. Just, can be a lot of typing sometimes. If you come from Java, this won't be a problem. But if you're used to things like JavaScript, where you can do a lot of things dynamically and introduce a lot of magic, it gets messy. And if you use a Haskell, it can get a little messy too. I'd like to talk to you mostly, though, about PureScript, which it started out as sort of a competitor to Elm. They sort of vary dramatically in how they focus on building the language. PureScript, I like to think of that as sort of an improvement on Haskell, which is a very bold statement. It's sort of taking what we learned building Haskell and trying to sort out the iffy bits that you can't really change in Haskell now, even though Haskell's motto was to never become so popular that you can't break it every year and nobody will complain. They haven't really done that. There are a lot of issues in Haskell, and they are trying to clean them up, but it's hard because so many people use it. PureScript doesn't care. PureScript breaks. We just had a release like yesterday, which broke everything essentially, and I've tried not to move my talk to that release, so hopefully it still works. Anyway, it compiles to JavaScript. This is the important bit. It's not a replacement for Haskell. It's a language that compiles to JavaScript, which happens to look extremely much like Haskell. And PureScript, instead of avoiding category theory at all, it goes like, well, actually, I think you'll find, Haskell, that you've done this bit wrong. Maybe we should sit down and fix it. Like, in Haskell, a monad is a functor. Oh, I said the M word, I'm sorry. A monad is just a functor, but everybody knows that you got the inheritance chain is monad applicative functor. And in Haskell, 25 years ago, that wasn't the case. We didn't really use applicatives much. We didn't realize they were a good thing to have. And that remains in the Haskell prelude to this day. But in PureScript, they fixed that right from the start. They've introduced a lot more crazy category theory in the base library. PureScript is essentially, well, Elm is for people who rather wouldn't want to deal with too much math. PureScript is for people who really like math. It cares about types even more than Haskell does, which is also a very bold statement. It's sort of the opposite of Elm in that respect as well. Elm has a type system and it works very well, but there's a limit to what you can express with Elm's type system. With PureScript, essentially, the sky's the limit, which is a very bold statement because it can't do dependent types or anything like that. It's not quite Idris yet, but in many ways, it's more powerful than Haskell, and in some ways, it's not, but it's getting there, I assure you. Right. I'd like to show you Halogen, which is our latest attempt at building a UI library for PureScript, which takes some steps further than Elm does. It cares more about types, as I mentioned. It uses, well, essentially the type signatures get fairly complex. I'm going to just start off by showing you some. It's got the same architectural principles as Elm, but it gets sort of heavy on the categories as we go. Don't worry if you don't follow this completely. We're going to end with doing some programming, and you're going to see that even if you don't understand all the technical bits here, it's still quite usable. So this is essentially what the UI type looks like in Elm. This is PureScript now, but it's fairly identical to what you saw in Elm. It's a signal which yields an HTML document. But we'd like to introduce what sort of events can come out of that document so we can type those more carefully. So we changed that from a signal that yields HTML to a signal that yields HTML with an event type attached. The event in this case is a type variable, which means it can be any sort of type, but it's going to be the same type always, and it's going to be called event. Moving on, we realized that we don't have the actual event loop in here. So we introduce a function instead of just the signal, a function that takes you from the input signal to the output signal. The input type is still our event type, and the output type is an HTML document which yields our event type. And Halogen in the background will tie this knot together. Moving on though, we realize that this is, we can generalize this a bit. We've made ourselves a signal function, which is a step further from signals in that this is getting closer to a state machine. Don't worry too much about the definition of the signal function there. It's essentially, what you need to realize is that it takes an input type and an output type, and there's sort of a state machine in between there. And so we convert our original signal function into a more formalized sort at the end there. A signal function which takes an event as an input and an HTML document with events coming out of it as the output. This is how the type looks. I see I need most of my time for the programming, so I'm not going to bother explaining that too much. But essentially, it's sort of like a fold. It's got a current value, it's got a way of figuring out the next value by calling functions, and there's a mechanism behind that. And mostly what you will do is just actually turn it into a fold. The stateful function is like the fold P in Elm, and all that does is it takes an initial state, the S, and it takes a function which will take the current state and the input event and produce a new state, and it returns the signal, which yields that state as it's processed. So this is just about exactly like a fold or a reduce or a catamorphism, if you like the simpler words for these sorts of things. And I'd just like to add one more thing to that. We got the event loop sorted now. But I'd just like to add this M part here, because, well, essentially everything's better with a monad in it. And the reason we put a monad in there is quite simply, notice we put the monad on what comes out of the document. We can put any sort of monad in there. Usually it will be an I/O monad, or something that goes off asynchronously and maybe fetches something from a database before the actual event is produced. So it can trigger like a call to the server to pick up some data, which in turn generates an event containing the data that you fetched, which can be fed into the model. So everything's better with the monad in it, of course. Now, this eventually turns into a component, because in Halogen we have the idea of components as well. A component takes a monad, it takes a request and a result, which is the input and the output. And that's just a signal function. Now, how do you compose these components? Because I've been sort of leading up to this, haven't I? It's got to be a lot more clever than in Elm. Well, look at the puppy. Look at the puppy. Isn't it adorable? Let's talk about tricky things like that. Because actually, no, it's essentially just as complicated as an Elm. I've been assured that they are working on a new and much better way of doing this. It's going to be ready in a week or two. Apparently, it's not there yet. So, unfortunately, Halogen doesn't have a neat solution for this, which means that in my example, I'm not going to try composing things together. But the good news is that signal functions are profunctors, which is a very cool word. Which means that even though it's definitely still not elegant to compose these components together, it is slightly, very slightly less work than in Elm, and you get to use the word profunctor a lot. Here's Edcomet, the birth of the profunctor. And essentially, an application in Halogen looks essentially like this. The UI is essentially a component, and you got the main part of the program, which just calls the run UI function, which takes a component. It will return you the DOM node that it's rendering in, and a driver function, which is something you can use to feed events manually into the main loop. And we just put the nodes in the DOM, and Halogen deals with the rest. So what I'm going to do now is show you this in action, unless this breaks. So, I have got some boilerplate for you here. The main function I just showed you, I got a and this is the append to body function that just puts a node into the DOM at the right place, which is called down here. We've got a state and we got an input type, and the only event is nope, and the state has nothing in it. And this is the component function. It essentially uses stateful to get us a signal which runs the update function. The update function is down here, on our state as we receive inputs. And we map render over that. Essentially, render takes a state and produces HTML. And the HTML we produce with our empty state is, well, something about ponies. Let's see if it compiles. It takes a little while to compile that. The next version is like 10 times faster compiling, but it breaks everything, so I can't use it. Okay, so I thought I'd write a very quick little application, which is essentially like a to-do list, except let's make us a list of ponies, which we can add to with an input field. Which means we start with the most essential stuff. Type pony, a string. And we add a list of ponies to our state. And actually, I'm just going to add the state of the input field as well. That's going to be essentially a string reflecting the contents of the input, just so I don't forget it later. I'm not going to add any inputs yet. I'm going to enrich our state with some ponies. Going to use Haskell's very strange style of indenting lists. Applejack and Fluttershy and Rarity. That should do for now. 3 ponies. And the input field is going to contain an empty string. Okay. So let's, instead of just saying ponies rule, because that's pretty obvious, I think, let's render our list of ponies. So this is sort of a DSL in PureScript for writing HTML. It's essentially, there's a function which generates a UL tag in this case. And if it normally takes two lists, a list of parameters and a list of children. But the convention is if you put an underscore at the end of it, it has no arguments, it just takes a list of children. And the list of children, actually, it's not going to be an empty list, it's going to be the render pony function mapped over ponies. So let's create the render pony function. It has a type from pony to an HTML document. Render pony takes a pony p and returns a list item with some text, and the text is p. So I think, unless I made a mistake, which the compiler will tell us about. Yes, of course. I think that was probably what it was complaining about there, because we got an error. It's just the error message doesn't fit on the screen. But yes, of course, we need to, this is a type error, we need to extract ponies, and we need to extract pony, which is a pony waiting to be created in the input element yet to be created. So compiling again. Oh yeah, it works, good. Applejack, Fluttershy, and Rarity. That's great. We need to add more ponies there. We need to have a facility for adding more ponies. So I'm going to add a form, and when you submit it, actually I'm going to have to add some events now, because things are going to start happening. We're going to have a new pony event, and we're going to have an entry field updated event, which will take a string essentially. So that when you type in the input box, entry updated pony gets fired, and this pony here gets updated. And when new pony gets fired, we take that pony and we put it in the list of ponies. And on submit, this will take a function, a lambda function, which first of all calls prevent default, otherwise we're going to reload the page, which is not what we want. And then it creates a new pony event. Further, the input box itself, it's going to have a type of text, and it's going to have a value of whatever is in the pony variable, and it's going to have an onValueChanged event of creating an input event which creates entry updated, and this a.input function will create entry updated with the contents that have changed as its first argument, which means that we get an entry updated with a pony. And I'm missing something down here. No children. And I'm not quite sure about the indentation here. Let's see if the input box appears. Yes, we have an input box. And so I can start adding ponies, right? Ah, no. Doesn't even recognize that I've changed the field. Actually, I need to implement this update function now, don't I? So I've created two events. I created new pony and entry updated, and I need to deal with, let's start with entry updated. So the update function gets the current state first. Let's get the ponies out of that, and we don't care about the entry field, because entry updated gets us a new value for that. So we just overwrite what was in there previously. List state ponies E. So now when I type a pony name, compiling, it's at least not the slowest Scala. Let's be happy about that. Now, when I hit enter, it doesn't do anything. I keep hitting enter now, you can't see it. But it remembers the state of the box at least. Now, let's see if we can add the pony. Because I'm out of time as well, so this is going to be in the nick of it. List state, ponies, pony. New pony is new list state. And let's make it sorted. And then take the first pony and cons it onto the other ponies. So they're all in there together. And we switch the input field into the empty list, into the empty string. So the pony that we type when we hit enter goes away. So that should be our application if this compiles. Okay. Rainbow dash. Well, that works. Okay, let's finish this. Twilight. Sparkle, very good. And? Oh, Trixie, good one. Final scratch. You're all doing this deliberately, aren't you? Obviously, Pinkie Pie. Because Pinkie Pie is actually best pony. Now you know that much at least. Okay, that's a good list. Very listen to. Just for completeness. Actually, what I would have done if I hadn't just gone 1 minute over time is I would have implemented a quick delete facility as well, because we don't want Larry Ellison on our list of best ponies, obviously. So, I have just shown you very quickly how to do web application in Halogen. And I hope that was at least vaguely interesting. At least you got to see some pony GIFs. So that'll be it for me. Thank you ever so much.
I think we have time for one question, maybe two.
So what questions do you have?
Yeah. What was the difference between type and new type?
Oh, new type it's essentially the same thing. No, data and new type are the same thing. But new data, the representation in JavaScript for data is an object containing various implementation details, whereas new type gets the exact value that you put into it. So if you have a new type with an int in it, it's going to be represented in the compiled JavaScript as an int, not an object containing an int. That's essentially it. It's for performance mostly. But the difference between type and new type is that new type can have type classes on it, type class instances.
So maybe this is something you addressed already, but like I was thinking, all the application state was there, like in a single data.
Yeah.
So is there some way to divide it somehow, like in a real application? You probably want to.
Yeah, as I mentioned, you can, with a bit of effort, you can create subcomponents that you can reuse. But we're not very happy with how that is done right now. Likewise, in Elm, it's still sort of clunky, but I know they're working on it, and they're probably going to come up with something extremely clever. But in Halogen, I'm told that within a week or two, we're going to see their new idea for this, which is going to be absolutely brilliant. Allegedly, we'll see.